Hello guys, in this video we are going to have a simple introduction to geometry node simulations in Blender. And it has lots of capabilities and it has a very vast world. But first, we need to learn basic concepts to be able to make more complicated simulations. So in this video we are going to focus on the concepts and also we are going to make a collision functionality. And yeah, let's dive into it. Okay, we are going to first delete everything and make a huge plane, 10 meters, and also going to geometry nodes. Distribute some points on it first. First let me set it to 500. And of course we can change the radius. Set point radius. Set it to 0.03 for the beginning. Okay. Now here we can bring simulation zone. This simulation runs everything in here in the zone which we specify for it at each frame. Okay, it means that it will do all this stuff and gets back to the beginning at the next frame and will do all this stuff again and again at each frames. So let me show you a simple example. For example, let me use set position. If here is my point at frame 1, I want to move it along x-axis by, for example, 0.1 meter, okay? Like this. I should give it a vector to move it to the next position. So it will move to the new position, and at the frame 2, the simulation will get back and do all this stuff again, which in here is only set position. So it will move it by 0.1 along x-axis to the new position. And also at the third frame it will do this again and goes on to the end. Let me bring the timeline. Okay, let me check. Okay, now let me make it more complex a little bit using noise texture. The noise texture values are between 0 and 1 and I want this range of number to be symmetric, so I want this to be between minus 0.5 to 0.5 instead of 0 to 1. So I use vector subtract. This is a vector math node and set it to subtract here and subtract it by 0.5. And at last I want to use a scale to have control over the magnitude of this vector. Now let me run it. Okay, the noise is small. Let me reduce the scale. Lower roughness. Okay. And also lower scale. I want everything to happen slower to see exactly what is happening. Okay. By the way, if you saw that the things aren't working for you, just hit this button and jump to the beginning and start it again. What is happening in here? Let me just focus on a point. With this set position and this noise texture, we are giving it a vector And for example, if it is at frame 1, it will move to the new position, and at the frame 2 it will get a new vector. But this vector is following the noise pattern, and this noise texture is giving a color, a 3D color, by the position of the point. It's like just giving it a position, no difference. So when the position of this point changed to the new position, so it will get a new color, means we'll get a new vector. So at the frame 2 it will have a new vector to move to another place, something like that. And also it was at the third frame. Okay, it will move to the position following the pattern of this noise texture. So we will have such thing like this. Okay, that was the principle. Now in here I don't want this noise texture. I just want to make an effect like a tornado or a black hole. I want these points to spin around a handler. First let me just make the handler. Icosphere with the radius of 0.15 is okay. Okay, this is my handler, and I want all these points to spin around it. Okay, so now how should we do this? As you saw in here, the simulation is more about vectors. You should specify vector at each frame and the points will move along that vector. Okay, this vector of course could be velocity, could be acceleration, or displacement, which we are using in here. We are focusing on displacement. Okay, let's say this is my handler, and this is my point in here. I'm just focusing on one point. If we have a straight line between these 2 points, the point and the handler, for the point to spin around my handler, there should be a vector at each frame like this, which is perpendicular to this line. And if this is my vector, this is the vector which we have, because we have the position of the handler and also the position of the points. And this is what we want. In some situations that we need a vector that is perpendicular to the vector that we have, it's good to always consider the cross product. Well, the cross product is like this, that the cross product of 2 vectors, A and B, will give us a vector C, which is perpendicular to the both of these vectors. And the magnitude of C is, if the angle between them is theta, the magnitude of this C vector is the magnitude of A dot magnitude of B dot sine of theta. Okay, so in here we have one of the vectors. For example, we have the vector A, but we don't have the vector B to use the cross product to achieve that redundant vector. But we have actually the vector B. I can use simply the Z vector, which is like 0, 0, 1. Okay, the cross product of Z and this vector. I also want this vector to point toward my handler, because later I'm going to show you I want to add an extra force like a gravity to point toward my handler. So let me make this first. For having this vector, I need to subtract. If this point is B and the point is A, the vector should be B minus A to point toward the B, which is my handler in here. So I'm just dragging my handler and dropping here, set this to relative and get the location and use subtract. And for the position of the points, I have the position node. Okay. Now I have my first vector, and the second vector was pretty simple, Z. actually a normal vector along z-axis. So I'm using cross product, and in here I can just simply write 0, 0, 1. And in cross product, the order matters. If you just swap these vectors, we would have this c vector in the negative direction or in the reverse direction. Okay. Now that I have my vector, I can use the scale to have control over the vector's magnitude and just plug it into the offset. And of course it should be very big. Let me play it. Oh, it vanished so fast. Let me just set this to 0.07. Okay. You can see that all of the points are spinning around my handler. Let me move the handler. Okay, you can see that it's following this handler, trying to spin around the handler. Now we have some problems in here. Let me just bring the handler back to its position. Okay, as you see in here, when we play this, all of the points are moving simultaneously. And why? That's because the points farther than the handler have higher velocity than the closer points. Something like this. If this is the point, it has a smaller vector, and the farther point has a bigger velocity vector. And why they have bigger vectors? Because we use the cross product to make this vector, and the cross product was between the z vector, which the magnitude is 1, but this vector, which is the subtraction between the location of the handler and the position of the point. As you can see, the magnitude of these are different, so it has direct influence on my final vector in here. Okay, and I don't like this effect. I want the closer points to move faster and the farther move slower. So in here I can normalize all the vectors. It means that all of them should have a magnitude of 1. Let me check it. Go back. Okay, you see? The closer points are moving faster. And as you can see, we are having a hole in here. And that's because of the inaccuracy of this process. Well, let me show you why. If this is my handler, and this is the point, if I use a big vector to move this point along the vector, as you can see, it's pushing this point outward to the outer place of this circle, which the point should move on it. Okay? So for having more accuracy, it's better to break these steps. I mean, instead of having one big vector, I can break it to 2 vectors and 2 steps. Well, I'm gonna show you later, but let me just give a simple explanation. If I break this step to something like this, and a smaller vector at the first step, and move the point to here, and then I will do that again, okay? As you see, it's better. As the steps are getting smaller, we are getting more accuracy. It's definitely better than have a big vector like this to move the points outward, okay? Now let me just add another force in here. As I already mentioned, I want to have my gravity. Let me delete them. Which I wanted this vector to point toward my handler. So this is the vector, and I'm going to normalize it again because I want to have same magnitude for each points, and I scale that, and finally add them together. Okay. Well, the scale should be so much smaller, like 0.004. Now let me run it. Okay, let me change the handler position. It doesn't work. Let me just reset it, reset everything again. Okay. And please let me increase this n to 1500. As you can see that the points are trying to move toward my icosphere, and that's because of the second vector which we added. Okay, now I'm going to show you how you can add accuracy. Let me just group these with set position, Control G. Okay, and as I already mentioned, for giving more accuracy we should just reduce the scale of these steps, like to half, break them to half, 0.035 and 0.002. But we are going to do this again, have two steps. So we reduce the step length to half, but we double the steps count. So we should have the same result but with more accuracy. Now let me check it. Go again. Okay. Now let me turn it off again. I also forgot to tell you that you can just scale it at the end instead of changing these scales. This can be a ratio between these two forces, but this is the ultimate scale. I can scale them down to 0.5. Just first let me show you the difference in the accuracy. We can check the whole size. Okay, that was one step. And now we are going for the two steps. Okay, as you can see, the hole got smaller, not as big as before. It means we have more accuracy and you can increase the steps. And of course, you can change the ratio between those two forces, like decrease the spinning speed and increase the gravity like this. Okay, let me check it again. Okay. And this was the basic. Well, you can play with these ratios. You can make the gravity even stronger at the beginning or at the closer points, and make it weaker for the farther points. And for that you can just use the length of this vector, which is the distance between the handler and the points. You can use the length and you can multiply it to whatever vector you want to play with. Okay. Now I'm just going to bring it back to the lower accuracy because I want more speed in here. Because in the next step we are going to work on the collision function. Okay, what collision means? Let me say if this is my point, if this is my current point, which I'm focusing on. It has a radius. Actually, all of the points have the same radius. And also this one has radius. First, we are going to focus on one point, and we can see that this point is inside its nearest point. Okay, collision means 2 points shouldn't be any closer than this distance, which is radius multiplied 2. Okay, this is the minimum distance that 2 points should have. So for making the collision functionality, we should check for each point that if they have closer distance than 2r, and we pull them out of each other. Okay, so like in here, when we have the distance and we see that the distance is lower than 2r, so we should pull out the current point which we are focusing on, and this point actually should move along this vector outward. If this is my focusing point like this, it should move out along this vector. And as you can see that it's all about this vector. And how can we get this? It's like actually this one. Okay, well, I have the position of the current point, and this is the nearest point, and I can get the position of the nearest point also. So by subtracting the position of the current point by the position of the nearest point, I can get the vector. But how much should I move this point, the focusing point, out of the nearest point? I can just pull it out by the vector with the big magnitude. Because if I move it too much outward, it might get just into the other points, which is in the other direction of it. Like in here, if I pull it too much, it would get inside this point, and I would have my problem again. So as you can see that we can't do it just in one step. Accuracy is exactly what we need in here. So we need multiple steps with very small steps, as small as possible, of course considering the time of calculation. And there is a fact we need to consider, that this calculation is simultaneously happening on all the points. In here I was just talking about one point, which I was focusing on, but it's actually happening on all the points. It means it's also happening on this point and on this point. So all of these calculations are happening on them. So it's better to have smaller steps to pull them out a little bit, and then check it again on all the points, and then pull them out a little bit again. And also we should check that again, and check that again and again. Okay, this is how you can achieve more accuracy. Now let me show you in the geometry nodes. We're going to have set position to make the first step. As I said in here, we need to get this vector. First, if this is my B point and this is, let me change the pen color. If this is my B and this is A, B is the position of the current point. So I can get the position, and I should subtract it by what? This is my nearest point, okay? And there is a node called index of nearest. By this I can find the nearest point and get the index of it, and based on the position. So I'm using this position in here. It's like just getting another position, doesn't have any difference. And since I got the index of the nearest point, I want to calculate the position of the nearest point, which is my point A. So there is another node called evaluate at index. Okay, we connect the index, and I want this to be vector because I want to calculate the position, so I can again connect the position. And this is actually the position of the nearest point, which I have the index of it by this node. Okay, So this is my point A, and I'm going to use it in the subtract. Now I have my vector. Now I need to check if the vector, which is the distance between the A and B, is less than or greater than 2r. So I use the length, which is actually the vector math, and set on length in here. And I want to check if this distance is less than, and this node is the compare node, and we are going to compare this one with the radius. I'm going to have my point radius by this node and multiply it by 2, multiplied by 2. Okay, so if the length is less than 2r, then we need to have the collision functionality. So here is where I need this vector. Okay, so in this situation, if the result is true, the output is 1, and if the result is false, it means if the distance is not less than 2r, the output would be 0. Okay, so as I said, I need this vector. This is my main vector. I need to scale it by the output of it. But the output 1 of this compare node is too big for my vector to be scaled by, because as I said, I want a very small step for the magnitude of this vector. So I'm going to multiply this by 0.03 and plug it into the scale and scale to the offset. Let me check it. Okay, as you can see, it seems that we already have collision functionality, but with very lower accuracy. And let me show you something. And as you can see that they are getting thicker in here. Let me show you. I don't like this. Actually, it's completely normal because of the collision functionality. Since my handler was higher than points at the beginning situation, and we had some forces toward my handler, so my points started to get z component. Okay, at first they were sitting on the xy plane and they didn't have difference in z direction, but after the simulation started and they moved toward the handler, they started to get different z positions. So the collision is also working between them along the z-axis. So it made them to move upward like this to maintain their distance. Okay, and it's okay for the collision function, that's right, but I don't like the look in here. So I'm going to multiply this by 1, 1, 0. It means that I'm maintaining the x and y component and I'm just getting rid of the z component. Okay, now let me check it again. Okay, as you can see, I got rid of that not pleasant effect, and also having my collision functionality along my xy plane. Of course, it has lower accuracy, so I'm going to increase it by increasing the step numbers. So let me go back, first group them. Oops. Also, we should include the set position, Control G. Okay, here's my step magnitude. I'm going to reduce it to 0.02 or 0.03. That's okay. It's the ratio of the distance, and here the 0.03 is small enough. If you already took a look at the Blender simulation demo file, you could see that this collision function is based on that file's collision function. And it's 0.025 there, magnitude for each step, and also used 10 steps for the collisions. I name it collision. I also group them. Okay, it was 10 collision steps there, and I'm going to just copy that. Of course, it totally depends on you and your desire for accuracy, because it's time consuming. So 1 2 3 4 5 6 7, good for now. Let me go back. Sorry, I forgot to say that we can give the variation to the points movement, and that's an important part. Well, we can add a noise texture. I'm going to use Voronoi noise texture, and you can well play with them. I just like to use Minkowski and set the scale to 0.8, exponent to 1, and I can use the scale at last step or even before this scale, doesn't matter, and connect the distance to the scale. Now let me check. Okay, you can see the difference. Let me turn it off. Okay, that was before using that. Now turn this on. Okay, that looks better. And at last you can increase the points and reduce the radius, and at last you can also set material to this, say particles, and call it here. Okay, now I'm going to show you my cached file. If you want to cache your simulation, you can go in here and internal dependencies. You can choose your folder for cache, and after choosing the folder you can go into the physics, and you should click on this plane which where is simulation happening, and this one will show up. So you can hit on the bake to bake from the start to the end of the frames which you specified in here. Okay, and you can also, by clicking this, delete that, and I'm going to show you the file. Okay, this is the file with the render, and this is without motion blur, and this is with motion blur, and this is with the color mixer. You can make such effect with this. You can go at the beginning. As you can see, I made 2000 points with 0.01 radius, and also for that coloring effect I stored color with noise texture. Just delete this map range, simple noise texture with this setting, and name the color. And of course I should go to the shader and bring the attribute node, call my attribute by writing its name in here, and of course using the color ramp, because in there I use the factor of the noise, not the color, to have control over my color in the shader. Okay, and also you can connect this to the principal BSDF And at first, this is like this. But when it starts to simulate, it starts to get mixed. Well, you can turn on the motion blur in here. And you can change the setting, but I didn't change the default values. And I think that's it. And sorry if the video just took too long. And as always, I wish you best, my friends. Goodbye.